Hello, this is Jiahui Wang. Our project is about movie recommendation, and my teammates are Enxu Han, Junbo He, and Shun Li. Just a quick overview. We are using IMDb Movies dataset, and we use this undirected and weighted graph to store the data. In our graph, the vertex is a movie, and two movies are connected if they are similar enough. The weight then will be 1 over the similarity of the two movies for the purpose of running the shortest path algorithm. We use this BFS to traverse a whole graph and use this graph coloring algorithm and Dijkstra algorithm to find shortest path in our implementation. And because we found our dataset on our own, so we have to do some data cleansing to get rid of invalid or irrelevant data. So this is what the dataset originally was. You can see we have title and year, genre, duration, country, and director, actors, and so on for each movie. And we noticed that some of the features are not that essential to determine the similarity between movies, such as budget, production company, and etc. So we deleted those columns using Excel, and we also deleted rows that contains blank elements like those. After this, we got our final dataset, which looks like this. For the vertex class, we store the features of each movie that we just saw in this format. And we've reused some code of the edge and graph class in the lab with some modifications to fit the new vertex object in. Then we do all the work in like making the graph and running the algorithms in the movies class. For two vertices to be connected, the two movies have to reach a similarity of 40. This is how we calculate similarity. They got points added when they have those similar features. Actors and directors are weighted more because they rarely matches with other movies. Edge weight is being assigned to 1 over similarity so that the smaller the weight, the more they are similar to each other. These two constructors read in the CSV file that we just saw and adds each movie as vertices to the graph. This is a problem because every time we insert a vertex, it goes over all the other existing vertices in the graph and calculates similarity with each of them. After that, can we connect the new vertex with other vertices? This will cause the program to run really slow. Our solution to this is that every time an edge is inserted, we write it to a file that keeps track of the edge connection and the edge weight. This way we can use the output file to connect vertices without calculating weight once again in the second time we run the same dataset. This is what the edge connection file looks like. So those two are connected together and this is the weight of the edge. And in fact, when we tested the constructor with 10,000 data, although the first time it took about 10 minutes to run, the second time it only takes 1.29 seconds. So here's an illustration of constructing the graph with 10,000 vertices using the edge connection file. So it only takes 1.031 seconds.
Hello, here's Oscar. Here I'm going to demonstrate the three algorithms we implement for our final project. The first one is simply a BFS traversals, and the BFS traversals will traverse our data sets in the BFS order and simply return the result. The code for our BFS. Let's see. Okay, here it is. It is very similar to the pursuit code on the class. And let's see the results. Because our data set is quite big, I will not gonna use all of them. I've instead used the first 3,000 lines of data. Okay. Just a second. here's the first 3,000 of code of our data sets. Okay, and let's see the next algorithm, which is the shortest path. Our goal is to return a path. The source one is which the source whose source is passing arguments, and whose destination is one that is a vertex among the vertices which are not neighbors of the source. And we want to make sure that among those non-neighbors vertices, the destination is always that one has the closest distance to the source, which means that they have the relatively high similarity. And now let's run the second algorithm, clear this up. Okay, I've already made that, so I'm not gonna do that again. Okay, here, shortest path. Just a second. It may take a few seconds. Okay, and let's, as you see here, we just find the shortest path for movie TT0004181. This one is the source, this one is the destination, and its path. Okay, and let's do another command, and this one lets you to specific ID you want. I will simply use this one as for demonstration purpose. Okay, let's go. Okay, here's the path for TT0005060. Okay, and now let's go over the last one, which is the graph coloring. Graph coloring is for demonstrate how many colors will be used to color the whole graph, and make sure that the neighbors will not have same color. So we will return return integer to which is the number of colors to demonstrate how complex our graph is. Let's see. Oh, here it is. Let's coloring. Okay, let's run this. Okay, and now our graph the first 3,000 vertices have 43 colors, and that's all our 3 algorithms. Thank you for watching. Bye.